Chapter 4, Proportional Reasoning and Statistics. We'll do Chapters 4 and 5, take a test on those, and we're nearly halfway finished with the book after this next test. So here we go. Chapter 4, Proportional Reasoning and Statistics, Section 1, Using Proportional Reasoning. Hopefully you've seen proportions in the past, in 7th and 8th grade, and this might not be anything new to you, if you already know how to do them. It says a ratio is a comparison of two quantities using division. A fraction is a type of ratio. Two ratios are equal to each other is known as proportion. Again, what I just said, a ratio. It's a comparison between two things using division. Examples of ratios, gear ratios. You know, if you've got a 3-inch to 5-inch gear ratio. Other examples of ratios, whenever you buy maybe model cars, it might say something like 1 to 12. To where what that means, 1 inch on the model car would actually, if you had the real car sitting there, if you took and measured maybe the windshield, let's say the windshield is 3 inches wide on the model car, then if it's a 1 to 12, that means it would be 36 inches wide on the real car. That's what a 1 to 12 ratio is. Every 1 inch on your model car is equal to 12 inches on your real car. That's a 1 to 12 ratio. Again, most of the time we write ratios as fractions. We'd write 1 to 12 like this. 1 inch on the model car, 12 inches on the real car. Two ratios that are equal are known as proportions. It's just saying this ratio equals this ratio. 1 to 12 equals 2 to 24 equals 3 to 36. They work just like fractions because a fraction is a type of ratio. So on example 1 it says finish each proportion. It's just simply saying give something that in the first one 3 to 4, 3 over 4. And again, you will hear me say 3 to 4 most of the time instead of 3/4 or 3 over 4, because even though it looks like a fraction, we are talking about ratios. So 3 to 4, this to this is how you usually say it. So 3 to 4, anybody give me a ratio equal to that? Yeah. 6 to 8. Why are they equal? Because they're the same thing as fractions. They work just like fractions. Take 3 to 4. Take the entire thing, multiply it by 2. What do you get on top and bottom? It's like the distributive property. You get 6 to 8. Multiply the whole thing by 3. What do you get? 9 over 12. 9 to 12. Multiply the whole thing by 4. What do you get? 12 to 16. Ratios are just like fractions. Any questions? Does everybody understand why those are equal? The second one, 7 to 10. Give me a ratio equal to 7 to 10. 14 over 20. Give me another one. You can multiply by anything you want to. Give me another one. 28 over 40. Give me another one. Give me another one. Any questions on how we're getting to equal ratios? You're taking top and bottom, multiplying by 2, 3, 4, 5. Can I multiply top and bottom by 100? Sure. What would that be? 700 over 1,000. It's the same ratio. Okay? It's kind of like you can think of it like this. 7 to 10. Let's say I have a bunch of money. Be nice. But I don't. I had a bunch of money. I'm going to give you 7 out of every $10. Okay? What if I had $1,000? I'm going to give you 700. That's what all this is saying. If I give you 7 out of every 10, what if I had $20? I'd be giving you 14 of them. Because 14 out of 20 is the same thing as 7 out of 10. I'm giving you 7 out of every 10. What if I had $40? How much would I be giving you? 28 out of the 40. What if I had $60? I'd be giving you 42 out of the 60. Because all of those ratios are equal to 7 to 10. The cross product, this is very important, the cross product of every proportion is equal. And again, a proportion is simply a ratio equal to a ratio. Or if you want to think of it as a fraction equal to a fraction, that's fine with me. The cross product of every proportion is equal. This is an important fact because later we will use this to solve proportions. Go back up to some of the ones we just listed. 7 out of 10 was equal to 14 out of 20. What I mean by the cross product, this times this, and this times this. Do you see they're across from each other? The cross products of a ratio, look what always happens. What's 7 times 20? What's 10 times 14? It's always equal. Go to some of these up here. 3 to 4 and 6 to 8. Didn't we say that was equal? What's 4 times 6? What's 3 times 8? The cross product of ratios are always equal. Let's go down here to the bottom. Example 2 says verify that the cross products of the proportions are equal. These are proportions. How do I know they're proportions? Because they're fractions and they are equal. That's all a proportion is. So it says verify that they are equal. Verify the cross products are equal. First off, 7 over 8, is that equal to 21 over 24? Why? Multiply by 3. There you go. Multiply the whole first one by 3, you get the second one. So obviously they're equal. But we want to verify the cross products are equal. 8 times 21 is 168. 7 times 24 is also 168. Good job. Are they equal? Yeah. We verified it. That's all that means. Verify, just show that they are equal. The second one. 3 times 10 is 30. 2 times 15 is 30. These two things must be equal then. And you can do that with fractions too. If I say, are these two fractions equal? You can do cross products and see if they're equal. 11 times 15, I don't know, is 165. 33 times 5 is also 165. Any questions? That's important to us. Because now, well, we're going to do kind of the same thing here. Are the following true or false? Are they equal? Okay, it's got a little question mark. We don't know if they're equal or not. Let's do the first one two different ways. Take 3/4 and change it. Can we change that into 6/8? Yeah, by multiplying it by. So are they going to be equal? Sure. What's another way we can do it? 4 times 6, 24. 3 times 8, 24. Are they equal? Yes. The second one. Yes. 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 That's it. 19 times 5. Anybody know that one? Nope. 95. 7 times 12. Are those two things equal? No. And you can write it like this. Remember the symbol we learned? 12/19 is not equal to 5/7. You know a third way you could actually do that? Does everybody know how to change that to a decimal? What's this symbol mean? That's just division. 12 divided by 19. Type it in your calculator. That's decimal. 5 divided by 7. Type it in. If those decimals are not equal, those aren't equal. It shouldn't be. That's 19 divided by 12. You're doing 19 divided by 12. You got to be careful. And the last one here. We want to know, are they equal? The first method that we talked about a while ago is actually easier on this one. 4 over 21, 16 over 84. Use the first method I talked about. Can we change 4 over 21 to 16 over 84? Yes, if you multiply it by 4. 4 times 4 is 16. 21 times 4 is 84. Let's use that second method as well. 4 times 84. 84 times 4 is 336. Right? Yeah. 21 times 16. Obviously, it must be 336 because we said they were equal. So you don't really even have to multiply them out. We can solve proportions with the missing parts using the same idea. Look, guys, we got a new type of equation. A new equation, okay? Watch very closely. We've talked about tons of different types of equations. Here's a new one. We talked about linear equations to where you got to move the pluses and minuses over. We talked about 2, 3-step, 4-step, multi-step. We did solved inequalities. Algebra, guys, is all about what is x. Finding x. What's the missing part? And that's all this is. Find the missing part. Yes. The first one says 13 over 2 is equal to 65 over x. Is that right? You sure would. Y'all remember that from last year? Do you remember it? Let me show you why. If these two things are equal, if they are equal, I just showed you that this times this must equal this times this, right? Because think back, 3/4 equals 6/8. We said 4 times 8 is the same thing as 3 times 4. 4 times 6 is the same thing as 3 times 8, excuse me. So therefore, in this problem, 13 times what? Must be equal to 2 times 65. Take and let that soak in. Yes. Yes. 13 times x must be the same thing as 260. Does everybody understand why? Because cross products are equal. So therefore, what is 2 times 65? 130. So 13x equals 130. Guys, that is a one-step equation. All you've got to do is move the 13 over. How do we move 13 over? Divide by 13, and you do get x equals 10. And we'll talk about the shortcut in just a second that you were talking about. There's a shortcut makes these things a whole lot easier. The second one says x over 3.5 equals 5 over 2.5. X over 3.5 equals 5 over 2.5. Since these are proportions, what makes this a proportion? Fraction equal to a fraction. That's it. Two fractions equal. That makes it a proportion. Since it is a proportion, then what times what is equal to what times what? 5 times 3.5 is equal to 2.5 times x. What is 5 times 3.5? 17.5 equals 2.5 times x. How do you get to x by itself? Divide by 2.5 and you get x equals 7. Any questions? It's pretty easy.